All right, so now that I've shown the definition of the right triangle definition of the trigonometric functions, I wanted to use it in this example here. So the task is to find the values of all 6 of the trigonometric functions for the angle A. And it's important that we keep the right perspective here. So this is with respect to A in this diagram. So when we talk about opposite and adjacent, that needs to be relative to the angle that is our input in the trig function. So in this case, angle A. So the side opposite of angle A is this side down here, the one that has length 1. And the side adjacent to A, well, so there's these two sides that are touching angle A, or that are part of angle A. One of them, the one that's opposite of the right angle, is the hypotenuse. Which I had to, okay. And whose side length we don't know at this point. And then the other side touching A will be what's considered the adjacent side. So one thing I would take care of right away then is to find the length of this missing side, which is the side opposite of angle C, so I'm going to call that side C. And we need to note that that is the hypotenuse. So in the Pythagorean theorem, or that equation, a squared plus b squared equals c squared, the missing side in this case is the hypotenuse, the c squared. So we have A, the side that's opposite of angle A is 1, so this is a squared. B, the side that's opposite of angle B, has length square root of 5, so this is going to be square root of 5 squared equals c squared. So 1 squared is 1. The square root of 5 squared, these are inverse operations, so we end up with just 5 when you square a square root is equal to c squared. So 6 is equal to c squared. And so if we take the square root of both sides here, we find that the length of C is equal to the square root of 6. So the length of this side C right here, thinking about how I can write this clearly for you guys, is equal to the square root of 6. Mission not accomplished on writing that clearly. Hang on. Let's get rid of that and just, this is C, which has length square root of 6. Okay, that's better. All right, so now, right triangle definitions of the trig functions. I copied it from the notes here, but it's kind of in the way, so I'm going to actually delete that. Oops, I want to make sure I only delete this. Okay. All right, 6 trig functions. I know I talked about during the Zoom session yesterday. So sine of A, so we use this SOHCAHTOA acronym to remember these ratios. Sine of an angle A is equal to the ratio of the length of the opposite side over the length of the hypotenuse. That's the OH part here. And so in this case, sine of A is length of the opposite side is 1 over length of the hypotenuse is the square root of 6. I'm not particular about rationalizing denominators. This is just fine to leave your final answer like this for sine of A. Cosine of A, so that's the AH part here, that's adjacent over hypotenuse. So that's the length of the adjacent side, which is square root of 5, over the length of the hypotenuse, which is square root of 6. And yeah, I mean, I guess I would prefer to write that all under one radical, but if you want to leave it as square root of 5 over square root of 6, that's fine with me too. I'm really not picky about that, especially at this point. Tangent of A, tangent, that's the OA part here, so that's opposite over adjacent. So the opposite side has length 1, the adjacent side has length square root of 5. And that's all you need to do for finding these trig the values of the trig functions if you know the lengths all the sides of a right triangle like this. Now, that's only 3 functions. Now, the instructions here say 6, so let's talk about that. What I started to say earlier in the Zoom session, I said I consider these like our tier 1 trig functions. Tier 2, those are the reciprocal functions. And so finding those values is not too bad as long as you remember which function is the reciprocal of which one, or if you have that information handy. The reciprocal of the sine function is the cosecant function. So if sine of a is equal to 1 over the square root of 6, then cosecant of a is equal to the reciprocal. If we flip that, it's square root of 6 over 1, so I'll just write square root of 6. So there's the value of cosecant. Let me give myself a little more room here. The reciprocal of the cosine function is the secant function. So secant of a, if we just flip this over, is square root of 6 over 5. And the reciprocal of the tangent function is the cotangent function. So again, we flip this over, square root of 5 over 1, so let's just write square root of 5. And there you go. I know it's a bit messy, but we've got the values for all 6 trig functions. Sine of a is equal to 1 over the square root of 6. Cosine of a is equal to the square root of 5 over square root of 6. Tangent of a is 1 over square root of 5. And then we've got cosecant, secant, and cotangent.